In lesson 11 in this session, we're going to continue with subtracting fractions, and today we're going to talk about method 2. We're going to be working with the same problem, 1 3/4 minus 3/5. Just like before, we want to identify our original fraction or our starting amount, because in a subtraction we need to make sure that we are always taking away from that original amount. The original amount is 1 3/4, and we'll be taking away parts of that. Step 1 is still to analyze for an estimate so that we can check the reasonableness of our answer. And we do that by looking at our whole numbers. We have 1 and 0 because there's no whole number there. So what we can look at for an estimate is 1 minus 0, which is equal to 1. So when we get to our answer and we're checking for reasonableness, we're going to want an answer that is near or around 1. Step 2 still remains similar. We're going to rewrite our mixed number, our whole number mixed with a fraction, as an addition sentence, and it's going to be our whole number plus our fraction. So how we would write that is we would take the 1 down, and it would be 1 plus 3/4. This is still 1 3/4. We've just kind of decomposed it when taking it apart. And then we add in our other subtraction, minus 3/5. We also want to make sure that we're keeping track of our wholes, because when we're doing our subtraction, we want to make sure that we are taking away from our whole numbers. So step 3 is we're going to rename our fractions and subtract. So this is different than the first method because we're leaving our whole number as a whole number. But now we're going to take our 3/4 and our 3/5 and rename those. So we're going to rename our 3/4 by making an equivalent fraction, and the way we make equivalent fractions, keeping the value the same, is by multiplying by 1, and we can rename that 1 to another fraction. And then we're subtracting 3/5, but we need to rename 3/5 because we have to have like units. And the same thing, we'll be multiplying by 1, but we can rename that 1 to help us get our equivalent fraction. Our conjecture is that we multiply the numerator and the denominator of the fraction we're working with by the denominator of the opposite fraction, which here is 5. So we're going to multiply by 5/5. So we've renamed our whole to 5/5. And then over here, we're going to rename our whole, multiplying the numerator and denominator by the denominator of the opposite fraction, which is 4. So we're going to rename our whole to 4/4. And then we will want to continue rewriting our equation. So we leave our whole the same. And now we have our equivalent fractions. Our whole amount of parts is going to be 4 times 5, which is 20. And then the parts that we have is 3 times 5, which is 15. So we've renamed our 3/4 to 15/20, or 15/20. And then we're subtracting. And our whole amount of parts is 5 times 4, which is 20. So we see right here that we now have like units in our whole. Then our numerator, or how many parts we're taking away, 3 times 4, which would be 12. So with this method, what you're going to do is you're going to want to do the subtraction part first, where normally when we are working with PEMDAS, we start here at the right and start at the left and we work towards the right. But here we want to do the subtraction first and take away those like units. So we're going to leave the whole the same. And we're going to have the addition sign there, and we're going to work this problem. In subtraction, our conjecture says that our whole remains the same amount of parts, so our whole is 20. And then we can subtract the numerators. So I had 15 parts, and I'm taking away 12, so I'm left with 3 parts out of those 20 parts. Finally, we want to solve and simplify. So 1 plus 3/20 is we just put those numbers together. So we have 1 and 3/20. And then we can think about simplifying by asking ourselves, can we make bigger sized parts? So having a smaller denominator. And we think about, can we divide both these numbers by anything? And since we have such a small denominator, we can start thinking about that and asking ourselves, could I divide both of these by 2? 20 you could divide by 2 evenly, but 3 you can't divide by 2 without creating more parts, so 2 wouldn't work. And then we'd go up to 3, which is our numerator, and we can ask ourselves, could we divide by 3 to make whole numbers? 3 divided by 3 would be 1, so that would be whole, but 20 divided by 3 wouldn't equal out to a whole number. It would be another fraction of a part. So my answer to 1 3/4 minus 3/5 is 1 3/20. And if I connect it back to my estimate answer of 1, I can tell that this answer is reasonable because it is close to or around 1.